All right, so we're going to talk about geometric series here, which will be the sum of the terms of a geometric sequence. So why don't we quick review what a geometric sequence is. It might look something like this, where basically the pattern involved is involved in multiplying by some common ratio. Okay, in this case it would be 2. So just again, the general formula to get the nth term would just be a sub n equals, it's just whatever you're starting with, we call a1, times that common ratio to the n minus 1 power. Okay, so for this one specifically, it would be, you could get the nth term by starting with 2, we're timesing by 2 to the n minus 1 power, and that could get you any term in the sequence. You know, if you want the 100th term, you would just plug in 100 for n and kind of calculate that out. Okay, so that's the review. What we're going to turn our attention on now again is the series, which means, you know, adding up the first n terms. The sum of the terms is what makes it a series. And again, there are some formulas and shortcuts to do that, so you don't have to actually add up every individual term. You know, you don't want to add up 500 terms. So there's going to be a little way to do that. Okay, so let's look at where this formula comes from. It's a little bit confusing on how to derive the formula, but I do want to just kind of walk through it instead of just magically showing you a formula. I want to show you a little bit on where it comes from. So again, the idea is we're adding up terms. So we're going to do a1 plus a2 plus a3 all the way up to a sub n, however many terms we want. So specifically to geometrics, remember arithmetic has its own formulas that was in a previous video. But when you're dealing with the geometric sequence, the idea is that the sum of the terms, if you want to think of it, is going to be the first term, okay, plus the second term. And remember in geometric, the second term is just the first term times r. Okay, and then the next term is just timesing by r again, right? So that's why it's r to the second power, and then timesing by r again, and so on until you get out to the nth term. And that's basically just what our explicit formula said the nth term is. It's a1 times r to the n minus 1. Okay, so that's what we want. We want the sum of this. And here's where it gets kind of tricky, and I'm not sure how whoever made this stuff up figured this out, but it's pretty nifty. What they decided to do was take that equation we have right there and basically multiply both sides by r. Okay, so we're going to distribute in r. So what'll happen is the left side, if you multiply by r, it just becomes r times s sub n. And I'm actually just multiplying each of these terms. Every single term here is getting multiplied by r. So the first one, you take a1 times r, that's here. Okay. And then when I multiply the second term, that one by r, it became that term. And I just wrote it, I lined it up this way for a reason we'll see in a second. Basically, that pattern continues. If you were to take this last term and times it by another r, it would just make the exponent on the r become 1 higher, which would just become n. So again, this is kind of what would happen, and this is going to lead us to our formula. That's all we're doing here is showing where our formula is about to come from. Okay, because the trick is then, we want to know what is s sub n. So we want to solve this thing for s sub n. Okay, and so the reason this is going to work nice is if we were to subtract the two equations. Okay? So literally subtracting straight down. Notice what would happen. We would have the Sn minus Rs sub n is on the left side of the equation. But the reason I wrote it this way and lined it up this way is because when we subtract, that cancels that, that cancels that, that cancels that. All this middle stuff cancels. That kind of cancels. And notice the only things that are left are a1, and then we're subtracting this. So that's why we're getting what we have over here. Okay. And again, the reason this is going to work is because on the left side, algebraically, it's Sn minus R sub S sub n. So what we do is we factor out an S sub n, okay, and we factor out an A1 on the other side of the equation. Okay, again, all that's going on there is algebra. This is just a common factor that I bring out front. Okay. On the other side of the equation, A sub 1 is a common factor that I factor out. And what it allows us to do is solve by just dividing both sides by 1 minus r, and that gives me S sub n equals a1 times 1 minus r to the n all over 1 minus r. Okay? And that's the formula we're going to use in order to find the sum of the terms. All right, so again, going back, our formula that we just derived, we showed where it came from down there in the bottom. That'll get you the sum of the first n terms, as long as the sequence is geometric. Okay, so let's use it and see what it can do for us. Here's an example of a sequence, and we'll do some review stuff on parts A and B and then get to the new topic there. But basically, let's figure out, is this sequence geometric? So it's not really obvious what we're multiplying by, but just remember, you can always check and see what the ratio is if you take a term and divide it by the term before it. If you take 12.6 divided by 7, and in this case that would actually equal 1.8. Okay, and then just double check that that pattern continues using the third term divided by the second term. Okay, and that would verify to me that that also equals 1.8. So I can see this sequence is geometric. We have that ratio of times 1.8. Okay, so that's going to be our R value. So the formula to get a term in the sequence, remember for geometric, it's always the first term times that common ratio to the n minus 1 power. Okay, so that would be our explicit formula. Again, that's just to get a single term, not the sum of the terms yet. That's old stuff review. Then to get the 15th term, we now have an an n value that we can use. So I would just plug in 15 for both n's, and we would calculate that value out to be 26,236.94. Okay? So that would be way out in the sequence if we were to carry it out to the 15th term. That would be the value there. Okay, here's the new part. Can we find the sum of the first 15 terms? So again, if you want to list all 15 terms and add them up, that's fine, but just remember, you could be asked to find the sum of the first 10,000 terms, and that probably wouldn't be an option. So you're going to want to know the formula and how to use it. Okay, so the new formula from the previous slide is sum of the first n terms. So it's a1 times 1 minus r to the n over 1 minus r. Okay, so what we're going to do is just plug values in that we know and get a sum. Okay, so again, a1, of course, was the first term, which was 7. So 1 minus the r value in this case was 1.8. That's getting raised to the 15th power. Okay, and then the denominator is just 1 minus r. So a couple notes, it does not use n minus 1 like most of the other formulas. And also note that it's the only thing being raised to the power is the 1.8. It's not, that exponent is not outside the parentheses, it's actually inside the parentheses. So let's kind of walk through how to calculate that quickly and just make sure that it works out. Okay, so I'm going to do 7. I'm just going to use parentheses. 1 minus 1.8. Now that 1.8 is getting raised to a power. Then we can close the parenthesis, and we're dividing that whole thing by, in parentheses again, 1 minus r, 1 minus 1.8. And this should give us our final answer. That should be the sum of the first 15 terms. Okay, if we were to add them all up, it would be over 15,000 total. Okay, so let's write that down. So that's going to be the sum, 59,024.36. All right. Can we express the same sum using sigma notation? Okay, that was in one of the previous videos. Basically, sigma notation is a shorthand way of writing a sum, and we're going to think about starting with the first term up through the 15th term, because that's what they want us to do. And then if you remember how this worked with arithmetic sequences, we just put an explicit formula in there. So it's going to be what we had answered, I believe, in part A. Yeah, right here's the explicit formula for the sequence. So I'm just going to put that in. 7 times 1.8. I'm going to use x just because that's what the calculator uses. Okay. And we should be able to verify that this would get us the same value using the sigma notation, so we can do that real quick. That one's under math for the bottom of the list here. And again, this was covered in the previous video as well, but it's going to be a variable of x going from term 1 to term 15. So we can add up 15 terms and then put the explicit formula just as written. Okay, and remember this one is this is the formula for the sequence, so it does use x minus 1. And hopefully we get the same answer, and we do. Okay. All right, so let's do one last example where we are given some different information. Okay, let's think about, um, they're telling us the sum of the first 20 terms of a geometric sequence with a ratio of 2 is this big number. So what is the first term? Okay, so again, formula for that, for geometric sum, is always a1 times 1 minus r to the n all over 1 minus r. Okay, and we should know some of the pieces, and we should be able to find the one we need. So let's see, what do we know? Do we know the sum? The sum of the first terms is that big number, so we know that. We know n. All right, so n up there, they told us n is 20. And they also told us the ratio, right? The ratio is somewhere 2. Okay, so let's start plugging in, and we'll do some algebra and solve this. The sum again is that big sum, 314, 57, 25 equals, okay, a1 we don't know. We're trying to find what the first term is. That's our unknown. 1 minus the ratio is 2. There are 20 terms, so 2 to the 20th, all over 1 minus 2. And let's see if we can solve that. We'll do some algebra and simplify. Okay, so what I would do first, let's just, we got here 31, 4, 5, 7, 2, 5. A1 times 1 minus 2 to the 20th. Now that denominator, 1 minus 2, of course, is just negative 1. So I would first just multiply both sides by negative 1. Okay, equals A1 times 1 minus 2 to the 20th. And then all we got to do if we want to solve for A1 is just divide sides by 1 minus 2 to the 20th power. 1 minus 2 to the 20th power. Okay, so let's do that on our calculator and see what we get. So we will take the negative 314, 725, and use of parentheses is key here. We're dividing by a quantity, so in parentheses 1 minus 2 to the 20th power, close parenthesis, and this should give us our final answer, and ends up being 3. Okay, so we know the first term in that sequence must have been 3, and that's what they needed to know, so that was it. All right, so that's using the formulas and then using the calculator a little bit with geometric series.